First, let me start by asking a couple of very natural questions that you might have when considering whether to take this course. The first one is, what is software engineering? And the second, very related one, is why do we need it? So what I did was actually to go out and ask some of the main experts in the field, both in academia and industry, these very questions. And let's see what they said.
What is software engineering and why is it important?
Okay, can I start with another question?
Of course.
Okay, first, what is a computer? It's a programmable device. So the essence of computing is programming. So program development is basically the most essential use of a computer. So software engineering is the discipline that investigates program development. So how can it be done more efficiently? What's the best way of doing program development? And how can you develop reliable programs? So that's how I define it. But I consider any software development activity a software engineering activity.
Software engineering is the systematic application of methods to build software in a rigorous way. And I think one of the aspects that I like to bring into the notion of software engineering is that it's something that involves not only kind of technically building the system, but understanding the requirements, working with stakeholders, trying to find a solution that balances all of the stakeholders' needs in order to deliver the software in a way that's tested and is rigorous to meet the needs of the stakeholders.
Well, software engineering is the whole process of creation of software using engineering principles.
My view is kind of a holistic view, and I think about it from the perspective of how is software engineering different from programming. So I think that research about programming is all about the create part of software, and that software engineering is about the entire life cycle, so that's one aspect, and the other aspect of the definition is it's about quality, the quality of software. Software engineering even considers things long after you ship, which we all know is it is the largest economic piece of software development.
To improve software engineering process for better software productivity and quality.
The set of activities that one engages in when building software systems or software-intended products, it's fundamentally a value-creating activity. It involves social processes.
Software engineering is the act of many people working together and putting together many versions of large and complex systems. And well, our world depends on software. Software is immensely complex, and you need many, many smart people to build these things.
Well, engineering, I think, is the activity of envisioning and realizing valuable new functions with sufficient and justifiable confidence that the resulting system will have all of the critical quality attributes that are necessary for the system to be a success. And software engineering is the activity of doing this, not only for the software components of engineering systems, but for the system overall, given that it's so heavily reliant on its underlying software technologies.
So I would say software engineering is the kind of art and practice of building software systems.
Software engineering, in a nutshell, is a set of methods and principles and techniques that we have developed to enable us to engineer or build large software systems that outstrip or outpace one engineer's or even a small team of engineers' ability or abilities to understand and construct and maintain over time. So it requires a lot of people, it requires a long-term investment by an organization or a number of organizations, and oftentimes it requires support for systems that are intended for one purpose but end up getting used for many additional purposes in addition to the original one.
Software engineering is about building and constructing very large-scale, high-quality systems. And so the high quality is the big issue.
Software engineering is an engineering discipline of developing software-based systems, usually embedded into larger systems composed of hardware and humans, and business processes, and processes in general. And why is that important? Well, because software is pervasive in all industry sectors, and therefore systems must be reliable, safe, and secure.
But can we just get that by sitting down and writing software?
Well, you could if software was small and simple enough to be developed by one or two people together in a room. But software development now is distributed, involves teams of people with different backgrounds who have to communicate with each other. It also involves customers, clients, users. Software engineers have to work with hardware engineers, with domain experts, and therefore, well, no, we can't simply sit down and start coding.
Software engineering is mostly being able to program, and you need to be able to put big systems together so that they actually work. That's my simple definition.
If you don't use software engineering practices, you're not going to be able to put them together?
Well, you're not going to be able to reliably put them together. So basically, you can maybe hack something up, but it's not going to necessarily stand the test of time. If somebody wants to change it, it's probably going to break.
And it's important because if you don't think about how you're building the system and how you're trading off different aspects like performance and scalability and reliability, then it's going to end up breaking or not lasting very long or not doing everything that you want it to do or being really expensive.
If it's not done in a principled way, it will be bad and every user will suffer. That's why we need software engineering.
Why is it important? Because, these two goals, productivity, faster in terms of developing software, and higher quality would be apparently important because software is everywhere.
It's important because we use software in everyday life. Everything's built on software systems, and these are ubiquitous across our society.
It's important because software is everywhere around us, and the way we build it and the way we maintain it is something that determines almost the basic quality of life nowadays. And getting that software right can make a difference oftentimes between a really fun product and one that you won't like to use, a reasonably successful company or one that fails, and in more extreme cases, even the difference between life and death if you think about the software that runs in the airplane on which many of you fly on a regular basis.
There are programs everywhere. If they screw up, we are all screwed.
Software engineering is crucially important because it's the engineering discipline that is uniquely capable of carrying out the engineering mission for software-reliant systems.
In the US, we've all seen an unfortunate example of a system that went badly wrong in healthcare.gov, and that system wasn't engineered correctly. And I think if we look at the reasons for that, they stem back to somewhere at the intersection between requirements and architecture and politics and project management, and all of these things are important concepts that have to go into the software engineering mix.
It would end up in lots and lots of chaos because people wouldn't know how to organize themselves and wouldn't know how to organize software. Many of software engineering is very simple rules that you need to apply properly in order to get things done. And people look at these rules and think, these rules are so super simple, this is totally obvious. But once you try to apply them, you find out they're not obvious at all.
Now that we heard these experts, let me show you an example that illustrates what can happen when software engineering practices are not suitably applied.